Hi guys, in this lecture today I will try to describe a geometric representation of a complex number. Here we can see a Cartesian coordinate system which will be called the complex plane. So we often speak of the point z equals x plus iy, as we can see here. The horizontal axis is called the real axis and the vertical axis is called imaginary axis. So we can also use a position vector for z. The distance from the origin to z, which is denoted by r or absolute value of z, is the modulus of this complex number. So it is evaluated by the formula r equals absolute value of z equals the square root of x squared plus y squared. We also have an angle theta here, which is called the argument of the complex number, denoted as argz. So to find this angle, you must solve two trigonometric equations, a system of trigonometric equations. The first one being cosine theta equals x over r, then the second one is sine of theta y over r. If you find this theta angle here, it is the argument of z. Okay, let's get to an example. Suppose that we have the complex number z equals 1 plus I square root of 3. First of all, we shall find its modulus, which is r equals absolute value of z equals square root of 1 squared plus square root of 3 squared, which is square root of 1 plus 3, which gives 2. After that, we shall find the argument of this complex number, which is argz, and now we shall solve the system cosine theta equals 1 over 2 and sine theta equals square root of 3 over 2. These two give argz equals 60 degrees or pi by 3 in radians. Now we can write this number z in polar form. The polar form of a complex number follows this formula. Z equals x plus iy is absolute value of z, and in a parenthesis we write cosine theta plus I sine theta. Okay, let's do it on this example. Z equals 1 plus I square root of 3. This is 2, its modulus, and in a parenthesis we write cosine pi by 3 plus I sine pi by 3. We can also write this complex number in exponential form. The exponential form is as follows: z equals x plus iy, which is absolute value of z times e, the number e, to the power of I times theta. So let's do it on our example. Z equals 1 plus I square root of 3 is 2, which is the modulus, multiplied by e to the power I times pi by 3. And sometimes in technical books you can find it in a different way, in a different representation, which is 2 and the angle above here as an exponent pi by 3. Thank you for watching this video.